Today we're going to start off with a new unit, and where we're going to talk about the applications of different forms of energy. So this is the first lecture for this particular unit today, and in the introduction part we are just going to revise some of the types of energy that we know with very few examples that we already have heard about. So as we all know that sun is usually the ultimate source of energy, but then when we come in tapping the energy, we are tapping it in different forms. Okay, so when we talk about something like mechanical energy, and we say it's a combination of potential energy and kinetic energy, electrical energy, chemical energy, depending on what kind of product we want to develop or what kind of application we want to put in use, we are looking into different forms of energy. Okay. So if we say energy, by the term we mean that it is the ability to do work. So that's the very basic definition of energy. So with this, let's start off with the unit, and first just let's have a look at the syllabus. What are the topics that we are going to learn in this particular unit? We're just specifically going to look into the application of material and their devices for energy storage. By that we mean that what is the application of the material which actually uses thermal energy, and then what are the devices that stores thermal energy, what are the devices that stores electrochemical energy. So as we've seen, some devices like battery and all, they are storing electrochemical energy. So many of these topics we have already learned. We are not going to go too much into the detail of that, but definitely we can have a look. Okay, devices storing chemical energy, devices storing electrical energy, something which is very common. Okay, and then magnetic energy, and then mechanical energy source. So all of these we are going to study. Okay, and then we are going to look specifically into nuclear energy, and we are going to talk about the application of nuclear energy in nuclear weapons, medical field, food technology, and environmental related issues. Okay, so we already have a very basic idea of these things. More or less this unit is going to be easy. It's not going to be very difficult. I hope you can get along this chapter easily. Okay, but let's just list down the most common types of energy. Okay, these are the energies which we have, and most of the times the energies are interconvertible. By that we mean that we can transform from one type of energy to another type of energy, and as we go through these topics in this particular chapter, we are going to look into these facts as well. Okay, so the very first example is mechanical energy. I'm going to come into each of these definitions separately. So I'm not right now. I'm not explaining what is mechanical energy, but let's just list them down. Okay. So we have a machine which is basically working. Okay, your car which is working. These are all employing mechanical energy. Then we do have thermal energy. So if you have a cup of hot tea, it's basically nothing but thermal energy. Nuclear energy, the applications are endless. Of course, the damages are also there. Okay, so whatever work you are doing in your lab and it is generating some kind of energy from some kind of chemical, basically we call it as the chemical energy. And then the sun is giving out the electromagnetic energy. So we use the radio wave, the microwave, and everything else, and that is actually nothing but the electromagnetic energy. Then we have got sonic energy. You have your tape recorder, so that's basically dealing with sound. And then gravitational energy, of course, the sign of apple. Okay, so apple falls, the gravitational pull, the earth is its position, the solar system works, the earth is revolving around the sun, and so on. So all these are actually a result of the gravitational energy. Now kinetic energy and potential energy, if we just combine them, we are actually going to get something which we call as thermal energy. Okay, and then finally the ionization energy. So I think all of you have heard about all these types of energy. Okay, and we are just going to look into one by one now, and then we are going to just stop here. Okay, and then we are going to talk about, first is nothing but the mechanical energy. So what is mechanical energy? It basically results from the movement or location of the object. So if you have a dam, okay, and then we know that you basically have some turbines there. Okay, so these turbines are there, and I want to rotate them, so I'll be putting some water source there. Okay, on the top I'll be putting having some water source at the top, and then this water source will have potential energy, and this water will fall on the turbine, and then it will actually get converted into kinetic energy. This turbine rotates, so basically therein comes the mechanical energy. Okay, so this mechanical energy is the combination of kinetic energy and potential energy. So if you take an example, a moving car is having a kinetic energy. So if you move a car basically up or down a mountain, it has kinetic and both potential energy. Okay, a book sitting on the table has potential energy, and so on. I think we have already seen these examples that when we say we throw a ball, okay, upwards, and then there is a kinetic energy, let's say half mv square, okay, and the ball reaches a point where it basically stops before it comes back. So at that particular point where the ball stops, this v becomes 0. So if v becomes 0, then the potential energy will become maximum. Okay, so these examples we have already learned before. Okay, so these are some of the things that we are revising. So this is basically a revision chapter. We already know these things. Okay, we are just going to look into it more deeply in the later sessions. Right now let's just concentrate on revising it. Okay, so thermal energy is next. So you basically have heat, okay, or heat energy, and it reflects the temperature difference between two systems. So if we go into thermodynamics, we talk about something which is called an adiabatic process, where we say that there is no exchange of heat. Okay, so that actually is talking about more or less about thermal energy. Okay, so if you have a cup of hot coffee, it has got thermal energy, and if you generate heat and have thermal energy with respect to your environment, okay, we can generate heat and have heat with respect to our environment. So when we talked about these thermal power plants, we heated and we got some steam, and that steam actually allowed the turbine to rotate. We're talking about thermal energy there. So at that topic of thermal power plant is actually totally based on something which we call as thermal energy. Nuclear energy, we have not discussed this in detail, but we already know that nuclear energy is risky, is dangerous. Okay, it basically results from the changes in the atomic nuclei or nuclear reaction, and whenever there is some kind of nuclear energy extraction, there is always the radiations coming out, the alpha, beta, gamma radiations. We have got in a fusion reaction, and we have got the fission reaction. In fission reaction, we have got more and more neutrons coming out, and then we have got the nuclear reactors. So everything deals with nuclear energy here, and then we talk about the alpha, beta, gamma decay. Okay, these are all nothing but nuclear reactions, and atomic detonation or power from a nuclear plant are specific examples of this type of energy. So in the in this particular unit, we are also going to look into some nuclear weapons. So atomic detonation is part of a nuclear weapon. Okay, and if we want to find out get the power from the nuclear power plant, these are specific examples of this type of energy. Okay, next is the chemical energy. Now the chemical energy results from chemical reactions between atoms or molecules, and there are different types of chemical energy. If you have heard about the term which we basically called as luminescence. Okay, so under luminescence we have got different categories like photoluminescence, fluoroluminescence, chemiluminescence, electroluminescence, cathodoluminescence, and so on. Okay, so in this we have got something which is called chemiluminescence. So that means you are going to get an output in the form of light. And why does that happen? Because there is a chemical reaction that actually happens. Okay, that is why you are going to get the output here. So if you consider something like a jellyfish which glows in the dark, that is basically nothing but a chemical reaction that happens, and that is chemiluminescence. Okay, so if you consider the electrochemical energy that we have stored in a battery, that is also an example of chemical energy. Okay, so chemiluminescence or electrochemical energy are both examples of chemical energy, and this actually results from the chemical reactions. Okay, so between atoms and molecules, very much self-explanatory. An electrochemical cell or battery, or as I said, a jellyfish glowing in the dark can be an example of chemical energy. Next is electromagnetic energy. So the radiation from the sun has been tapped in different ways. You are getting your mobile signals because of the radio waves. You are using a microwave oven, that's microwaves. Okay, and then you can see around you because of visible light, that is nothing but visible light. So that's again electromagnetic waves. Okay, so these are in the form of photons that we know, and these photons will actually carry some kind of energy which is actually utilized. What are the examples? So any form of light has electromagnetic energy, including the parts of the spectrum that we see. And then I think we know the application here: radio waves and gamma waves. We have gamma waves are actually very highly penetrating waves. Then we have got X-rays, okay, microwaves and ultraviolet light, etc., and so on. Okay, in fact, the infrared rays and all everything are basically an application of electromagnetic energy. Next, we have got the sonic energy. The sonic word basically comes from the word sound. So we basically have it generated from the sound waves. So sometimes you might hear a lot of thunderstorm and all. These are all nothing but sonic energy. Sometimes if we can actually just tap them to for some application, definitely that's the application there. Okay, and then sonic boom and all these terms you might have heard. Okay, and the point here is that sound waves actually needs a medium to travel through, so they will use a medium like air or basically any other medium. Okay, so it can travel through even water, but definitely the velocity gets affected. Okay, but if there is a medium, it can flow, but through air it's one of the faster mediums, okay, for the sonic energy to flow. So basically a sonic boom, okay, is a term. It is also included with the term like aircrafts and all. Okay, max speed and all, these are all related with sonic energy. A song played on a stereo, and your voice of course is nothing but sonic energy. So that's the application. I'm talking to you, you are able to listen to me via the speakers of your mobile phone on this online lecture. That is nothing but the transfer of sonic energy. Next we have got gravitational energy. So the energy associated with gravity usually it involves the attraction between objects based on their mass. So you know that if the mass is very massive, heavy, basically the gravitational pull is much higher. So that's where the gravitational energy comes into the picture. It basically can serve as a basis for mechanical energy, such as potential energy of an object placed on a shelf or the kinetic energy of the moon in orbit around the sun. So if you have the potential energy getting converted into kinetic energy in that turbine example where water falls from the top, it basically falls because of the gravitational pull. So there is the interconversion, and it is more or less related with each other. Okay, and gravitational energy holds the atmosphere to the earth. That is quite something which you already know. Kinetic energy, I don't think I need to explain much because you already know it, but this is basically because of the motion of the body. Okay, and it ranges from 0 to some positive value. It's never negative, because if you consider a child swinging on a swing, no matter whether the swing is moving forward or backward, the value of kinetic energy is never negative. I hope you have already seen this example of a pendulum, and if you have the pendulum moving in this direction and this direction, now if you just put a tap, the pendulum moves here, it goes at stop here and then comes back. Okay, so what happens is, if the pendulum stops here, V becomes 0, and then potential energy is maximum. Here also V becomes 0 and potential energy is maximum. Here potential energy is minimum. Okay, potential energy is minimum, but then V is not equal to 0, so there is a kinetic energy involved. Okay, so basically it's nothing but a constant conversion of potential energy to kinetic energy and so on. At some point, if you consider somewhere in the middle, it's basically a combination of both potential energy and kinetic energy. So that's why potential energy also plays an important role, and potential energy is nothing but dependent on the energy of the object's position. Okay, so again the same example, when the child swings, maximum potential energy at the end. Okay, close to the ground, her potential energy is at minimum. Okay, so it's the swinging example that we're talking about. So if you throw a ball upwards, at the highest point the velocity becomes 0, so the potential energy is greatest there, because kinetic energy becomes 0. As the ball rises and it falls in the combination of potential and kinetic energy. So these are some of the examples that we already know. These derivations also I think we have done before. And finally we come to ionization energy. If you have an atom and you want to knock out an electron, and if you put some external energy, the electron moves out, and that is basically nothing but ionization, right? So the energy which holds the electron to the system or to the nucleus, okay, to an atom, okay, or an ion or a molecule, is basically called ionization energy. Okay, so it is the reason why electrons are stuck onto the nucleus, okay, until and unless some external energy is applied. So it is applicable for atoms, ions and molecules, all three. So if you remember your chemistry, the first ionization energy of an atom is the energy needed to remove the electron completely. So if I want to just remove the electron completely, okay, for hydrogen it is minus 13.6 or 13.2 eV and so on. I think you heard about those values. Okay, we are not just going to look into this now, we are going to look into it in more detail later. The second ionization energy is the energy required to remove the second electron, and is greater than the required to remove the first electron. So if the electron is closer to the nucleus, it's tightly bound. Okay, and then you need more energy to remove it. Okay, so that means the ionization energy will be somehow higher. Okay, so that's all for today. This was just an introduction of the lecture. Okay, and in the next class we are going to look into different kinds of energy specifically. Thank you.